So we have a problem that requires us to solve simultaneous equations using Cramer's rule. So this is equation 1, equation 2, equation 3. So first of all, what we do, number 1, is that we write the main matrix. So main matrix, so that we have 1, then 2, -3, we extract the coefficients. So 4, then we have 3, we have -2, we have -2, then we multiply our x, y, z. This is equal to 4, a column of the outputs, which is 4, 33, and 2. So from there, we need to look for the determinant of the main matrix, which is going to be D. So we look for D, the determinant of D, determinant of this matrix may be M, okay, that has the values 1, 1, 1, 2, -3, 4, we have 3, -2, -2. So as we earlier on said, we get 1, we multiply it by this matrix that is the determinant of the matrix that is going to be created if I cancelled the row that has this first 1 and the column that had this 1. So I remain with whatever is here. So this is going to be get the products of the members in the major diagonal minus the products of the members in the minor diagonal. Major diagonal minus minor diagonal. So I will have -3 times -2. I subtract 4 times -2. I cross brackets, then I take a minus. Remember, I have to put a plus here, a minus, and a plus. So I take a -1 again into the matrix that is going to be formed when I cancel out the column that is having 1 and the row that is having 1. So that means I'll have 2, 4, 3, -2. So I'll have 2 times -2, 2 times -2, then minus 3 times 4. Okay, 3 times 4. Then plus this 1, so 1 times which, the determinant of which matrix, 2, -3, 3, -2. So I'll have 2 times -2, take away -3 times 3. So when I summarize this, I should be able to get, this is -6, then -6 minus 8. So what is that going to be? I'll have something like
Master, it is positive.
Okay, this is
you have
positive.
-3 times -2.
Good.
Yes.
This is positive, and this is going to be +8. So I'll have D equal to 14, because this is going to be 6 plus 8, and that is going to be 14. Then I'll have, obviously, this is 2 times -2, that is -4. -4 minus 12, I'll have -16. So -16, if I multiplied it into there, then into -1, so I'll have 16. Then plus, this is -4, -4 plus 9. So -4 plus 9, obviously I will have 9 minus 4, and this is 30 plus 5, which gives us 35. So finally, we have D, which is equal to 35. So that is 1. I go to dx. So the matrix for dx is going to be, we said, first of all, you look at the values at the extreme here for the outputs, the values for the coefficients. So if we are looking for x, what we are going to do, we are going to eliminate, first of all, the values that give us the coefficients of x. So the column 1, 2, 3 is going to be replaced by column 4, 3, 3, 2. So that means dx is going to be the determinant of a matrix that has 4, 3, 3, 2. Then we have 1, negative 3, negative 2. Then we have 1, 4, and negative 2. So this is the matrix that we are looking for, and the determinant is obviously going to be 4 into the determinant of this matrix. 4 into negative 3 times negative 2, okay? Then we take away, now 1 into, okay, sorry. So we have to take away now the product of the minor diagonal. So we take, this is going to be like this. So we
4
take
times
away,
negative 2.
yeah, we take away negative 2 times 4.
And 4.
Yes. So we again subtract 1 into, we have 1 into this and that. So we have 33. 33 times negative 2. We take away 2 times 4. Then we add 1 into this is going to be negative 2 times 33. Then we take away 2 times negative. So this is going to be 6. Now 6 minus 6 minus 8, that is 14 times that 4. What would we get? We would get 56. So this is 56 minus, I have negative 66, negative 66 minus, this is 8. So that is negative 74, but if I subtract that negative 74, it becomes a plus. So, then plus negative 66 plus 6, and that would obviously give you negative 60. So this is giving me a value that is equivalent to 70, because this is going to be 60, 130 minus 60, that is 70. So dx is equal to 70. Now we go to dy. So dy is the determinant of a matrix that is composed of the main matrix with the coefficients of y replaced by the outputs. So that means I will have 1, 2, I will have 3, then the y coefficients which are in the middle, I will replace them with the outputs, which is 4, 33, and 2. Then the coefficients of z remain, so I will have 1, 4, I will have negative 2. So this is going to be also 1 into, this is going to be 33 times negative 2. I take away times 4. Then I subtract. This is going to be 4 into obviously 2 times 2 times negative 2, then we subtract 3 times 4. So 3 times 4, which is 12. So I again add 1 into this is going to be 2 times 2 minus 3 times 3. I mean 3 times 33. So this is going to give us values that are equivalent to, if I get this is negative 66, I take away 8, so that should give us negative 74. So this is dy is equal to negative 74 plus, I have this as negative 4 minus 12, that is 16 times 4. So that should give you negative 64, but this being a minus, so I'll have minus minus. So it will be a plus 64. Then I come here, 2 times 2, that is 4, minus 99. So 99 minus 4, that should give us, this is 4 minus 99, so it will be minus 95. So this should give us a value equivalent to, this is going to be, if I add this is 10, so minus 10 minus 95, that is 105. So dy is equal to negative 105. So we go to the last one, which is getting dz. So dz is the determinant of a matrix that has the values of the z coefficients being replaced with the output. So I'll have the values of the main matrix, which is 1, 2, 3. I have 1, negative 3, negative 2. Then the values of the outputs are going to replace the coefficients of z. So I have 4, 33, and 2. So this is going to be obviously 1 into then negative 3 times 2. So negative 3 times 2, I take away the products of this diagonal, so this will be negative 66. So I subtract 1 into, so I have a matrix of 2, 3, 3, then 3 and 2. So it will be 4, 4, take away 99. 4 minus 99. Then we are adding a plus 4 into negative 4, then minus 9. So what is this going to give us? This is giving us negative 6 plus 66, because this is minus minus, so it becomes 66 minus 6, which becomes 60. Then what else is this going to give us? This is minus 95 minus 1, so it becomes plus 95. And finally, we have this being negative. This being negative. Let's repeat this and see. This is 2 times 2, which is 4. So this is supposed to be negative what? This is supposed to be, okay, sorry. This is supposed to be negative 4, then minus. So this is supposed to be a plus. So this is going to be 5 times that it becomes 20. So this is the 80 plus 95, which is 175. So meaning that dz is equal to 175. So what does that call us to do? So x is equal to dz, no, dx divided by d, and we know that dx is equal to 70 divided by 35. This is equal to 2. dy is equal to, so y itself be dy divided by d, and our y that we got was negative 105 divided by 35, and this gives us negative 3. Then z is equal to dz divided by d, and this is 175 divided by 35. So when I divide that, I get my z equivalent to 5. So finally, you'll say x is equal to 2, y is equal to negative 3, and z is equal to 5. So ladies and gentlemen, that's how we can solve this problem using